We are the Genius One design team and
Start
start start over.
my next start.
We are and it started yeah. We are the Genius One's design team for North Carolina A&T, and I am Nichelle'Le Carrington.
I'm Bobby White.
I'm Jasmine G.
And I'm Petronia Marshall.
And our project is a multi-sensor network. The objective of our project is to design and develop a multi-sensor network that is low powered and portable and receives data from certain vital signs. And communication of the network should focus on using health level 7 messaging standards, which basically is the standards for sending health information over a network of some sort. Our presentation consists of a title slide, introduction, presentation overview, motivation, requirements, specification, design, and conclusion.
All right. The motivation of our project. Basically, we looked at the industry of health industry as a home process. It's very expensive to do the health field in the home, but it's actually a more convenient way for us to monitor different patients who have different types of illnesses, such as like acute illnesses, like you got to take their blood pressure, your weight, things like that. They can get back to the doctor easily instead of a nurse or something coming out to the house to check on them constantly. One of our other motivations is the TI Innovation Challenge for 2013-2014. It's a Texas Instrument hosts annual design competition. The winner will receive like $10,000 at the end of the project, but you have to use TI products. You have to use 2 of their analog IC and a TI processor and 3 analog ICs. Now this is our requirements and specifications. The marketing requirements are listed from 1 through 6. It should rely data from the sensor, should be easy to use, should be easily maintained. The product must have a low cost, should be reliable, and should be durable. And in this chart, it just lists the engineering requirements and the justifications behind it. Each number has a marketing requirement, which states down here, tells you what it should be. One of the engineering requirements, the device must sync data to a central control system, and that's for the marketing requirement. That's listed under. It should be the data should rely data from sensor and should be easy to use. That's just one of them. And the justification for that was the general purpose of a project is to relay information from multiple medical devices.
Here we have a concept theme, which pretty much encompasses all the things we look for when it comes to parameters for our patient, parameters for how we intend to report the information gathered from the patient, and a little bit of data as far as our sensors that we'll use to gather information. So here, to the left, you have your sensors node. Attached to it, you have just a couple of sensors that we are pretty sure we're going to be using to pretty much acquire data from my patients. So we have a pressure sensor here, gas sensor, accelerometer, blood glucose meter, and actual scale for weight. Directly below the main node, we have vital signs, and these are pretty much, like I said before, the different patient parameters that we wish to track and monitor. So we have a blood oxygen level, blood glucose level, pulse, blood pressure, and weight. And pretty much these vital signs will be quantified using these sensors that you see to your node to the left. Our rightmost node, which is entitled Health Reports, pretty much explains or shows the different formats in which we'll report back our findings. So we have currently SMS, text messaging, voicemail, and email, and other notifications as well. So we're still kind of trying to develop what type of devices will be used to pretty much quantify the information and look at the information as we analyze, or as doctors may want to analyze. And moving a little bit further into the actual design, majority of this project is going to rely heavily on how well the sensor network works and how well our wireless connectivity all goes together. So for our wireless needs, we're pretty much using Zigbee, which is a specification for wireless communication. We chose this simply because of its previous applications in the healthcare field. It's low power. Well, Zigbee devices are low power, pretty cost efficient, and they don't require as much maintenance. All Zigbee devices are built upon the IEEE standard. And they're capable of being connected in a number of different type of networks. So, like you heard before, our actual setting for our project would be the home, at-home patient with some type of acute ailment that requires constant monitoring of the vital signs or other parameters. So we have a number of different network topologies that we can use to kind of make sure that we're getting data in the right places. Shown here is just 3. We have star cluster tree at the bottom and the mesh at the top right. The different circles pretty much show you, the different color circles show you what type of Zigbee device you're at each point. The yellow pretty much outlines our actual Zigbee devices as far as our sensors may be concerned, and then we have blue circles, which are our routers to get to ultimately get our information back to our Zigbee coordinator, which is in control of all of the wireless network communication research.
Moving on to the next part of our design, this is our level 2 block diagram, which is our basic system structure of how we want our wireless sensor network to work. First, we will start off with our recordings from our 3 devices, which would be our blood pressure monitor, our pulse ox, and our weight sensor. And then we'll move on to our Zigbee device, which will wirelessly transmit the acquired sensor data. And then we will transmit this signal and convert it from an analog to a digital signal. And we will use that using the AD converter and a low power microcontroller. Also, we will be including our RF transceiver in our project, which will receive all the data and send it to a control center, which is the basic purpose of our project, and we will compile a data report in the end. This is our Gantt chart. Our Gantt chart is based upon our work breakdown structure. We want to make sure that we complete tasks on a timely manner. So on a weekly basis, we have different things we want to complete. Some of those will be our preliminary design, which is basically including our block diagrams and understanding the workings of our project, and then moving on to the layout and the circuitry that will be included in our project. And software design will be researching what type of programming or coding languages we want to use. And then hardware design, which will be, we'll implement like the sensors, which sensors we want to use and how we want to connect them all. Well, in this Gantt chart, we'll just show at what point in our project we want to be doing each week going on next semester.
Once again, our project is based on a multi-sensor network that will rely on a portable device for at-home study of vital signs for patients, and we will use Health Level 7 messaging standards to send our information from the sensor network to the computer or smart device that we will use in order to record all of our data. Questions?
So, now you mentioned that you have like 7.6 million patient actually mentioned the conditions technology. So, do you have a reference for these statistics, or
Say it again.
She said you have a record for this.
Oh, the record.
The source book published by the American Association for Long-Term Care Insurance was where that actual statistic came from.
Okay, that's good. So if you can have like approximately compare how the patient can save money if they use the devices you are gonna design instead of like being in hospital and having this like rehab time, it's gonna be a very good justification for the device you're working on.
That's one of the things we're working on in order to make it more affordable for healthcare
Yeah.
and eliminate the doctor visits in between visits that aren't required.
That's right. I think it's gonna be
So you just want to kind of like for us to quantify everything, so we can like do a comparison of what it might be with your typical at home, and then what it might be using this particular system.
Yeah. Really, I have a question for you about the routing topology you're talking about.
I'm sorry, I didn't hear a word you said.
About the routing topology for Zigbee devices, so we have three options. One is the clustering, like the tree, and one is the star, and one is the mesh. So have you thought which one is the best option for you?
We haven't really discussed it as a whole, but I think we would start off just using the star topology, just because we're at this one location. We'll have a bunch of different patients that we're modeling. But I guess I really feel like the other two kind of come in when we move environments, I guess, or if there's more than one person in the house being monitored. But the start would be the start with the sart technology.
Yes,
which is the
actually, I
simplest.
think you won't have any router in your system because it's just sensor and one station. It's your microphone. I think this is star is going to be enough for the project. Then you can use like the 8.2.15 and also 0.11. They both have some protocols about the Zigbee devices, so you can take them and you can conclude and compare that why like star topology is the best for you. Yeah. Good job. I don't have any more questions for you.
Thank you.
As